Hello, everyone. Very happy to be here and talk to you about the how to apply data engineering best practices to data lakes. This subject is very close to my heart because when I was a CTO of a very big data company in Israel, I will tell you a little about this later, we were managing 8 petabytes of data over S3 on AWS. And I have seen how my application engineers were running engineering best practices and moving fast and getting results, while my excellent data engineering team, together with the researchers on that team, were really struggling to get new insights from the data and run things into production. So I did a lot of work trying to analyze why that is the case, and that is what I would like to share with you today. I'm currently the co-founder and CEO and mostly the co-creator of lakeFS, which is an open source project that we will briefly mention later. My company is called Treeverse. Prior to that, I was a CTO and a VP R&D of several Israeli startup companies. And the company I was talking about earlier is called SimilarWeb, and I've spent 6 years out of my career there. And the picture is because, except for liking data, I also like lakes. I'm an open water swimmer and definitely love data lakes. Okay, next slide. We would like to talk about how to apply engineering best practices into data engineering and data lakes. So let's agree first, what are the engineering best practices that we would like to consider? Of course, this is a very wide area and there are many good practices. But I would like to focus, next slide please, about the best practices that were born out of the agile methodology revolution. So as I'm sure you all know, till the late 90s of the last century, a lot of software engineering projects were actually failing because of the methodology by which they were developed, which is kind of the situation right now with data intensive applications. And what really made a difference was, can we go back to the slide? Thank you. What really made a difference is a change in the way, in the processes by which we decided to develop software and to launch software applications, and that is the agile methodology. To go very quickly on what it means having a very, very short feedback loop by constantly designing small things, building them, testing them, and launching them so that the users can give their feedback, possibly by measuring their behavior automatically, and then we can redesign the feature, improve it, or expand it, and so on. So we work with very, very quick cycles of software delivery. And what does that require under the hood from a tooling perspective? Next slide, please. So we would need to have CI and CD. That would mean that we would have to really automate the entire process of testing while developing, then building, and later on, of course, exposing into production, deploying and monitoring, and so on, in order to support this very fast feedback loop from the customers. And this is the best practices in software engineering that I would really like to focus on today. So development environment, CI, and CD. What does that look like, or what happens when we look at that in the data engineering world? Before we do that, let's take a very short, quick look on the next slide on the tooling that we have for software engineering practices. So we have, of course, version control for the code. Today we can also version control our infrastructure because we manage infrastructure as code, so we're actually using the same tools for that. And we have CI/CD automation tools. The first two are rather new, that just shows that we still have innovation in this field, although it's a very known practice. And we then have the artifact management tools, and last but definitely not least, the testing frameworks. We can see also that the tools that had given at the beginning version control, all based on Git, of course there are more, it's only examples, are spreading into providing CI and CD automations and artifact management. But the testing part is a completely different discipline. It really depends on the technologies that you have and the methodology that you need in order to test your code. But this is the tooling. It's a very vast world of tooling to support the automation that allows us fast feedback loops. And what happens in data? Next slide, please. So the world of data is a little different. It's different for several reasons that I'm going to share with you now. And basically, it's very different because it is dominated by the data itself. So let's take a look at what things look like in data. Next slide, please. So one click. We really would like to have a world where we just create a new data pipeline and everything is working and we can just sit outside with a beer and enjoy our new data. In practice, what happens is, next click, please, that stuff are not really working because, you know, someone just changed a tiny change in the schema and now everything is broken and we don't know even where to start with fixing that. And that is our day-to-day lives. A lot has been said about that. This one is actually something that I took from Iguazio, an MLOps platform. But that definitely captures the sentiment. So how do we deal with that? How do we go from having those fires to having this short feedback loop where stuff are working? We will talk about that. Let's first talk about why we're in this situation so we know what to fix. So we need to look back at the history and understand the evolution that we've been going through in the past, let's say, 20 years. Basically, what explains the evolution that you see here is the change in amounts of data that we need to manage. So we have moved from a world where data was small, at the left-hand side, in Egypt, where we used just relational databases to manage our data, and it was fine. We could just query them real quick, show a graph of what's going on, and everything was very, very simple through SQL. But the amounts of data kept on growing, and the number of systems within the organization that are holding data are growing, and hence we moved to data warehouses. If we were a very rich organization, we would even use Oracle. And we would then drive all the data from all the operational systems in the organization into a data warehouse, still a schema-based relational database, just stronger. But then that wasn't enough, or it became very expensive when it was enough. But at some point, it really wasn't enough. And we had to create a set of technologies to allow us to manage the amounts of data that we had. And this is where Hadoop came into the picture. And the storage underneath was HDFS. As time went by, the Hadoop ecosystem has evolved and improved, and most of the tools that we are using today for big data use some compute engine. I have now moved to the guy with the iPad there. So we are seeing distributed compute systems such as Spark or Presto, or I would argue Snowflake. And underneath there is an object storage. It could be a cloud-based object storage, an on-prem object storage, or an object storage that is provided to you by the database itself. But still, the technology separates the compute from the storage, and there are compute engines and object storages running together to allow us to really just analyze those amounts of data. So what we were doing in the last 20 years is just trying to get our heads around how do I actually analyze those huge amounts of data. And this is why we did not have time to talk about best practices. We were really just firefighting all along to survive and to present some data. And now that we do have those systems and they are working and they are stable, then we're looking into the future. And what we really want is this very, very short and simple list of having a mutable environment where data can change. Then we want to version the data. We want to have orchestration around all the jobs that are running our data. We definitely want to deliver it in high quality and high performance, and call the whole thing a lakehouse. To what extent are we delivering on that? That would be an argument that we would probably have with the people who are supplying the platforms that argue that they do that. But this is definitely something that we all aspire to build, either by building blocks or using a specific vendor. And this means, if we talk about high quality and high performance, that we are already ready to listen to some ideas about best practices. Let's continue. Another shift that happened in our state of mind is that instead of calling our data operations analytics or business intelligence or data pipelines or orchestrated pipelines or data operations, we now say that we deliver. Next click, please. Products. So we deliver data-intensive applications or data products. And when you deliver a product, it suddenly sounds like something that we have done before. You remember, with the Agile methodology and the CI and CD. So if we look at our internal data systems that are providing our internal data business intelligence as something that is an internal product that we are now responsible for delivering, and it has a production environment, and it needs to have high quality, then the whole way that we would be looking at it, and of course we would want to have that fast feedback loop with the users of our product, then all those things would drive us into the engineering best practices that I have mentioned earlier. Next click, please. But when we do that, we need to consider what the building blocks of a data product look like. So I try to be very general, but still specific enough so that we could have a conversation. So the very general points are that we all have the data itself. We all have code that help us analyze the data. That could be your SQL statements or your Python code, or if you're running bigger systems on Spark, your Java or Scala code. And of course, the infrastructure that you're running on, that is the compute engine that you're using. Again, could be Spark, could be Presto, could be any form of those managed, or if you're using Snowflake, then it provides a compute engine within the database, and then the storage or the database underneath. Some organizations run Spark over Snowflake. And of course, we have an orchestration. The reason we have an orchestration is that we would love to cut our data analysis steps to small testable tests, sets of calculations, and then just run them one after the other, or in some form of a direct acyclic graph, which is what orchestration tools provide us with, the ability to build a DAG. And we can see here a very, very small illustration. It is important to note that there is a difference between data products. There are a lot of differences, but a very clear difference between data products and software engineering products. And that is that with data, data goes in, data is the intermediate artifacts, and data is also what is delivered on the other side, possibly together with software. But there is no change like we have when compiling code, for example. So we need to manage the data in all states of managing the application. It's still data. Could be different formats, different data sources. It is still data. Okay, so now that we understand what are the building blocks for data products, let's see how do we run engineering best practices for it. Next slide, please. Oh, that's strange. I guess that is a better version of the slide we've just seen. So next slide, please. Okay, in a perfect world, what we would want to do is we would want to manage data products from development to production the way we manage software products. And let's take a look at what it means and how do we actually do that. Next slide, please. So first, when we want to have engineering best practices, we would need to have a development environment. Then we would want to have a CI workflow and then a CD workflow. So because we don't have much time, I will give only two examples. An example of the development environment, an example of the CD, and the more complex example of CI, I would be really happy to share with you if you ping me. So let's continue and see how we achieve it, starting with the development environment. So what does the development environment for a data product looks like? So first you have an isolated branch on your version control system for the code that you are about to change, upgrade, or add something to. You would need an isolated branch of the orchestration code. So when we orchestrate things in orchestration systems, it's either configuration files or actual Python code, and both can and should be version controlled using the same tool you're using for your code, for example, Git. By the way, if you are an analyst and you are writing SQL statements, those should still be managed and version controlled in Git. And dbt can help you do that, but you can also do that on your own. The third step would be an instance of the orchestration engine. So it's a best practice not to use the production cluster of the orchestration, not to load it too much, but have your own instance of the orchestration infrastructure. Again, if you manage infrastructure as code, that should be something that the organization can very easily automate for you. And in addition, you would have to have an instance of your compute engine, which is where you would run your code in order to get results over the data. The next thing, and the one that is very recent in being able to do, is have an isolated branch of the data. So no, we are not accessing production data, and we're not testing our development on production, but rather we can have a branch. Just like we have a branch of the code, we can have a branch of the data if the data is managed within a version control system that allows you to do so. There are such systems, and it is highly recommended to use them in order to get yourself a development environment that includes an isolated branch of your data. And the last and very important part would be a data quality testing framework that allows you, once you have created a version of the code that passes unit tests from a software perspective, you need now to verify that the results are in high quality from a data perspective. And this is where calling those testing frameworks that are specific to data become very critical within your development environment. If you have this package, you can now work in isolation as a developer or a development team working together. Get going with the changes or the additional features that you are adding to your data product, and know that at the end of this process, you are delivering high quality data to your consumers. And so that is the data development environment. Let's go over to the CD example. So continuous deployment for data products. That is not very intuitive to some data practitioners and software engineers, because this is a situation where the production code is the production code. We don't need a version of it. We are using production code. It's deployment of data. We are using the production orchestration because we are running in production, and we are using the production compute engine. What we want to have continuous deployment of is new data. So the only thing that changes in this system is that we have new data that we need to analyze. That could be because we are running our data product to calculate things every hour or every 5 minutes or every day. Whatever that would be, once we are running this product on the new data, while the code and the infrastructure did not change and they are intact, we can still encounter problems because the data itself is not in high quality. Something is wrong, there is change in characteristics of the input data, and that can cause an issue. In order to make sure that we are constantly in very high quality, we should continuously deploy data with testing. What that would look like, that would require us using the data version control system we talked about earlier. And if you look at the schema at the bottom of the slide, we start with just getting the data, the new input data that was just exposed from the ingestion process, and open a branch of the data. We now run our production pipelines on the branch. And at the end of this process, we create a hook, very much like GitHub Actions or GitLab's Actions or any other tool that you are currently using for code CD. And we then test the results of that pipeline, and we merge them back into the main branch where they are exposed to users only if the tests pass. If the tests for some reason fail, then we have the data on the branch at the time of the failure to debug it, to debug production, while production itself is intact. So very important to listen to the shift in the way we see things, right? So first of all, data that is exposed to consumers is production data, and we should treat it as production data. This is why if we add new data or we choose to change data on our main branch, that would be a merge action. You can even make your main branch protected. And then you know that if you have exposed data to consumers, it is in high quality, and if it is not in high quality, you have the ability to debug this. This will protect you from production issues related to low quality of input data. And next slide, please. So to support those concepts and many more, I just had only 35 minutes, and I do want to answer the questions. You need a tooling. So a lot of the tooling we've seen earlier is relevant for code, for the code of the orchestration, and for the code that manages your infrastructure when you run infrastructure as code. I just put Git as a placeholder, and of course the basis for all the other systems that we've seen. But when it comes to data, Git is inadequate. We don't really have time for that, but this is where lakeFS, the open source project that my team is behind, allow you to version control your data over your data lake. And then when it comes to CI and CD, you can use either lakeFS hooks or use the orchestration tools that you already have to orchestrate a CI and CD pipeline together with your version control. And of course, the observability domain is out there, and there are very many companies providing platforms and frameworks for data testing. I have put here only open source examples, just not to expose my favorites, but there are very many options out there. And once you integrate all those together, you can achieve CI and CD. Next slide, please. Very quick summary, and then I'll see if I have any questions that I need to answer. Next slide, please. All right, so get everything you can versioned in version control, your code, your orchestration code, your infrastructure configuration or infrastructure as code, your Terraforms, and make sure that it is all versioned and versioned together with your data. So use a data version control tool, and then create those workflows where you constantly test your results intermediates, and also full production data. Thank you. Well, I hope I pronounced the name correctly. Always interested in a free technical book. Oh, that is relevant for the book. Okay. The next question, Gautam. A fantastic talk. Thank you. Potentially a two-part question. How does lakeFS compare to other data versioning solutions like DVC and DataLad? In particular, does lakeFS or others allow for versioning data that will never live locally? E.g., well, you've asked and answered. So actually, lakeFS was built from a perspective of really big data organizations where the data is stored remotely and there is really no point in storing it locally. We do have feature requests to do that, and we might add that, but that is definitely not the center of the data versioning. While DVC, for example, works exactly like it. So there is a local version of the data that you can analyze. For me, it makes DVC more an experimentation during development tool than it is a full production system that can help you when you run your pipelines after development in production. While lakeFS, for better or worse, is managing large amounts of data on object storages. We have users using us over billions of objects and very many petabytes of data. That was the question. So if there are any other questions you want to put into the chat, I'll gladly answer them going forward. And thank you very much for listening.